Hello everyone, welcome back. We stop at question 35, so we are going to continue from there. So question 36 says, a force of 10 Newton acting continuously increases the kinetic energy of an object from 20 joules to 60 joules. Find the distance moved by the object. So there's a change in kinetic energy. So there's a change in the kinetic energy. So change in kinetic energy will be equal to 60 joule minus 20 joules, which will give us a 40 joules, right? And the force is equal to 10 Newton. So you're looking for the work done. Work done is the same thing as force multiplied by distance. No, you're not looking for distance. You are not looking for work done. You're looking for the distance, right? Okay, find the distance moved by the object. So remember, work done is equal to force times distance, and this is work done is equivalent to the change in kinetic energy, which is equal to force times d. So that implies the change in kinetic energy is 40, which will be equal to force, which is 10 multiplied by d. So divide both sides by 10. So that implies that the distance d will be equal to 40 divided by 10, which is equal to 4 meters. I hope this is taken. So anytime you see work done and kinetic energy or energy, work done is equivalent to the energy dissipated. Are we together? So that's about that. Question 36. So question 37. Question 37 says, an electric circuit consists of a resistor, a battery, and a key. If the voltage of the battery is increased, what will be an there will be an increase in the A, current and resistance only, B, current, resistance, and temperature, C, current and temperature only, D, resistance and temperature only. So here, remember your Ohm's law. Since if the voltage of the battery is increased, remember V is equal to IR. And this resistance here is a constant of proportionality. So that implies that increase in voltage will lead to increase in current. And when current increase in a conducting material, the temperature will also what? Increase. Are we together? So therefore, the correct answer here is option C. When the voltage is increased, current will increase, and as a result of that, temperature will increase. Okay. Question 38. 38 says, a radioactive material has a half-life of 1.0 hour. If 200 grams of it was present at 6 a.m. on a certain day, how many grams will have decayed by 9 a.m. the same day? So here, time of flight, or the half-life rather, is capital letter T, is given to be 1 hour, right? So that is the time it takes for the radioactive material to decay to have its initial number of atoms present. That is a half-life. So the initial number of atoms present, call it N1, is 200 grams. Please take note. So if it was present at this particular time, right, on a certain day, how many grams will have decayed by 9 a.m.? So now we are looking for time of decay, small letter t, time of decay will be equal to the differences from 6 a.m. to 9 a.m. That is 3 hours. So time of decay is 3 hours. Sorry, 3 hours. Now we're looking for the number of atoms that will decay. That is, let's call it ND, number of atoms that will decay. We don't know it. But after 3 hours, let us find the number of atoms that will be left. Number of atoms that will be left, call it N2. So we don't also know the number of atoms that will be left. Are we together? But we can find the number of disintegration, small letter n, which is equal to time of disintegration all over half-life. I hope you are following this step. So number of disintegration is time of disintegration all over half-life. That will give us time of disintegration is 3 hours all over half-life, which is 1. That is to say, this implies that number of disintegration is equal to 3. So we have disintegration ratio R, which is equal to 2 raised to power n. Please take note of this small formula. The disintegration ratio R is equal to 2 raised to power n. That will be equal to 2 raised to power, what is our n? 3. So that will give us a 8. Now this disintegration ratio is also equal to N1, the number of atoms initially present, all over N2, the number of atoms left. Are we together? So this implies that the disintegration ratio R, which is, what is disintegration ratio? 8, isn't it? Is equal to N1 is 200 all over N2. So our N2 will be equal to 200 divided by 8. So 200 divided by 8, that should give us 25. That should give us 25. Is that correct? Yeah, 25. So for us to get the number of atoms that will decay, that is ND, will be equal to number of atoms initially present minus number of atoms left. So that will give us number of atoms initially present is 200 minus number of atoms left, that is 25. So when you do that, we're going to have 175 grams. So 175 grams would have decayed after 3 hours. I hope this is understood. So the correct option here is option A, 175 grams. Okay, that is about question 38. Moving on. Question 39. Question 39 says, the following statement about a loudspeaker are correct except one. A, it contains a permanent magnet, which is correct. Sound signal convert, varying current signal enters this, correct. 2, option C, the current in the speech coil create a magnetic force on the coil, which is correct. The only odd one here is the magnetic force on the speech coil is unidirectional. It is not unidirectional because the signal changes, the sound speech also changes. So it is a multidirectional or bidirectional. So the correct answer here is option D. I hope we are together. So question 40 says, an ice cube has mass 220 grams at 5 degrees Celsius. Calculate the energy required to raise its temperature to 0 degrees Celsius, given that specific capacity of ice is 2.1. I have specifically have a problem with this question. I think it should be calculate the energy required to, to lower its temperature, right? Lower its temperature from 5 degrees Celsius to 0 degrees Celsius. Or it could be that the ice is at minus 5 degrees Celsius. Minus 5 degrees Celsius. Then, if it is like that, we'll be looking for heat gain, right? Heat gain to increase its temperature from minus 5 degrees Celsius to 0 degrees Celsius. So either way, I think that should be the correct one. If we are going to live here at 5 degrees Celsius, then the energy required here will be the heat its losses. I said the heat loss, right? That is what we're going to look for, the heat loss, not heat gain. Because by saying temperature required to rise this temperature, we are looking at heat gain. So if it's going to be like that, it will be heat loss. If you're going to leave it at 5. Otherwise, you take it as minus 5 degrees Celsius. Then you're looking for the energy required to rise its temperature to 0 degrees Celsius. I hope we are together. So let's assume it is negative. If it is negative, we are still going to use the same formula. You might have the same answer here if it is objective, but if it is theory, the ball game will be different entirely. Are we together? So in any of the way of the case, the heat loss or heat gain is equal to mc change in theta. So if we assume that here is negative, we are looking at a heat gain. So in that case, it's going to be equal to mass is 20 multiplied by specific capacity is 2.1, then multiplied by change in temperature, which will be what? Which will be 0 minus into bracket minus 5. So if you assume that here is minus 5 degrees Celsius, right? So heat gain or heat required to rise its temperature will be in this form. So in that case, you're going to have it to be, if you multiply this one, 20 multiplied by 2.1, then multiply by 5. So that will give us a 210. That will give us 210 joules. Are we together?